The domain is a set of all x values inside the relation or function, and the range is a set of all y values inside the relation or function. So for example, if we have this graph right here, where it starts at the point -1, -3, and keeps going on until infinity. And for the domain and range, there are multiple ways to write them, but in this video we're going to be focusing on interval notation. And to write domain, you need to put x, because the domain is the set of all x values. And you must write this symbol. And this symbol kind of looks like an E, and it means exists inside, and -1, infinity. And what this means is that, so this square bracket means that -1 is included, and it goes until the next number, infinity. And this parentheses means that it goes until infinity, but it doesn't touch infinity. So for example, if we had like -1, 4, it would go from -1, like here, and then say 4 was right here, there would be an unfilled in circle here. Hence why it stops at 4. It doesn't reach 4. And the reason why we put a parentheses around the infinity and not a square bracket is because nothing can ever touch infinity, but it can approach it, which is why we have the parentheses. And for y, and we have to write the same symbol, exists in square bracket, because -3 is included in this line, -3, infinity, because it also goes to infinity in the y coordinate, and parentheses. So this x exists in -1, infinity is the domain of this function, and y exists in -3, infinity is the range of this function. And if we have a graph like this, x can be any number. As you can see in the graph, x can go from -infinity all the way to infinity. So this means x exists in -infinity all the way to infinity. And when we have infinity or -infinity, remember we always have to put parentheses, because if we have a square bracket, that means it would touch infinity, which is not possible. And for the y values, the range, the y value can be anything under 1, because everything under 1 can go to -infinity, but nothing over 1 exists. But it also touches 1. So this means that y exists and parentheses -infinity, 1, square bracket, because 1 is included. So this is the domain, and this is the range for this graph. And if we have a graph like this, so what we need to look at first are the asymptotes. So the graph never touches x equals 2, and it never touches y equals 1. So for the domain, we need to find a way to exclude where x equals 2. And we can't just like start from x equals 2 or end at x equals 2, because there are points on both sides of x equals 2 that we need to consider. So what we would do in this situation is write x exists in. So first, it can go all the way to -infinity, so parentheses -infinity, 2, and it doesn't touch 2, so we write parentheses, and we write a u. This means that the thing before it and the thing after are both parts of the domain. So we would write just another one over here, from 2 to infinity, parentheses. So this is our domain for this. X exists in -infinity, 2, this symbol, which is called a union, 2, infinity. And for the range, we would do the same logic. So y exists in -infinity, 1, and it doesn't touch 1 or 2, so that's why we put the parentheses, union 1, infinity. And that is our range. And you might be wondering, why do we need to put 1 twice if we already put it once here, and then why do we need to put it again? Well, that's because if it doesn't here, we're stating that it doesn't touch 1 from negative infinity, but it approaches it. However, we need to say from the other side that from infinity, it also approaches 1 but doesn't touch it. As you can see, by looking at the graph, both of these sides approach y equals 1 but don't touch it at all. So that's why we need to put it twice. Now let's do an example problem. So in this function, the x value starts at -4 and it goes all the way here, and we have an arrow which means it approaches infinity. So the domain is pretty simple. X exists in beginning at -4, so actually we need a square bracket because it includes -4, -4, comma, infinity, and we don't know anything else. And the range is pretty similar. It starts at -3, and as you can see, the range or the y values approach infinity. So we can write y exists in square bracket -3, comma, infinity. So yeah, for this graph, this is our domain and this is our range. X exists in square bracket -4, comma, infinity, and y exists in square bracket -3, comma, infinity. And if we have a graph like this circle that's not filled in means that this point is not included in the function. So the function never touches -1, comma, 1. So for the x values, x exists in, it starts at -1 but doesn't actually touch it. So that's why we're going to put a parenthesis here. Parentheses -1, comma, and it ends at 5. So 5, and it does touch 5, so square bracket. So this would be our domain. And for the range, y exists in, again, it starts at 1, but doesn't actually touch 1. So, parentheses 1, comma, 3, because it ends at 3 and it does touch 3, so we're going to have a square bracket here. And this is our domain and range, and it explains the difference between the parentheses and square bracket. When you have the square bracket, you have like a shaded in dot like here, but if you have just like a white circle or an unshaded dot, then you use the parentheses. Now let's do some practice problems. If you think you know how to do this one, then pause the video and try it. But this problem asks to find the domain and range of this graph. So as we notice, we already have two asymptotes, one at x equals -2 and one at x equals 2. So this means -2 and 2 will both be excluded from the domain as they are not valid x points or valid numbers inside the set for all numbers of x. So let's write the domain first. X exists in, and let's check if it can reach -infinity. And yes, it can. From this line over here, it goes all the way to -infinity. So we can write -infinity, comma, and it ends at x equals -2, but it doesn't actually touch it, so we need parentheses. And since we have more domains or parts of the domain we have to write, let's write a union. And the next part again starts at -2, and this time it goes just to 2, so comma 2, but it doesn't touch it, so another parentheses. And we have a third part of the domain, so another union, and this time we started at 2 as we stated before, comma, and it goes all the way to infinity, positive infinity, so we can write infinity parentheses as it would never touch infinity. So this is our domain for this graph. As you can see, basically every single number except for -2 and 2, this is where the unions come in, where we can combine all three parts of the domain. And for the range, it's a little bit easier, but first we need to check again if it can reach -infinity. And whenever you're writing the domain and range, you always have to start from -infinity or the lowest number and go to the highest number. Like for example, I wrote here -infinity, comma -2, and then I wrote -2, comma 2, and then so on. I can't just start with -2, comma 2, and then write -infinity, comma -2. I have to do it in order, like as the numbers get bigger. So, back to the range, we can see that it goes to -infinity. So right, parentheses negative infinity, and then this actually goes to negative 1 as we can see on the graph. So negative 1, and it does touch negative 1, so we need a square bracket, but that's not all of the range. So again, we need a union. And then um, we don't know where these two top parts actually reach, but we can assume it reaches 0 because there's no markings or asymptotes. We can assume the asymptote is at 0. So it doesn't touch 0, but it starts at 0, so parentheses 0, comma, and it does go to positive infinity for the y-axis, so infinity, parentheses. So yeah, this is our domain and range for this function. Again, the x is the domain and y is the range. Now let's do another practice problem. If you think you know how to do this problem, then pause the video and try it. But this problem asks to find the domain and range of this function f of x equals 1 over x plus 1. Now, in this video, all we've done is find the domain and range of graphs that we can look at. We can look at like the points on the graph and stuff. We've never figured out the domain and range of a function written out like this, but it's still pretty easy to find out. Now for the domain, which is the x can be anything from negative infinity to infinity, but it can't be negative 1 because if you have 1 over negative 1 plus 1, you get 1 over 0, which is undefined. So let's write the domain for that. X exists in negative infinity because it can be negative infinity or approach negative infinity all the way to negative 1 union negative 1 comma infinity. Pretty simple. It can be anything except for negative 1. And for the range, you would think that the range could be anything because a fraction can be anything if the denominator is anything, but it cannot be 0 because no matter what you put inside the bottom, it can't be 0. Now, the closest we can get is if x was negative 1, then it would be 1 over 0, but 1 over 0 is undefined, so we can't get 0. So we get y exists in negative infinity, comma 0, union 0, comma infinity. And that's the domain and range of this function. It's pretty easy to figure out. You don't need to draw the graph out or anything. You can just think about it yourself. So everything that I just explained and all the problems that I went through should teach you everything that I need to know about domain and range and how to figure them out. If you learned something from this video or if you enjoyed it, then please consider liking or subscribing.